Hello everyone, this is Himabindu from the Department of CSIT. Today in this video, I would like to explain about the normal forms, which is a type of Greibach normal form. So here we have discussed two types of normal forms for the context-free grammar. So in that one, first one is Chomsky normal form and second one is the Greibach normal form. And in this video, I would like to explain about the conversion of context-free grammar to a Greibach normal form. What are the steps involved in the conversion of context-free grammar to Greibach normal form we will discuss. And here what is meant by normal form. In the previous video also we all discussed about the normal form, what is meant by normalization and why we go for the normalization and what is the minimization steps for converting a normal context-free grammar to a minimization of context-free grammar. And now in this video, normal forms are of two types. So in that one, we will discuss about the Greibach normal form. So here what is meant by normal form? By reducing the grammar gets minimized but does not get standardized. So here we will say that why we go for the normal form in the sense. So after minimization, there is no specific format is there in the context-free grammar. So we have to standardize that specified in a format way. So this is because the RHS of the productions have no specific format. So here we are after minimization, there is no specific format available in the right hand side of the production. So that's why we go for to standardize the grammar, we need a normalization. So here that's why we are going for the normal form. So here we have two types of normal form. One is a Chomsky normal form and second one is a Greibach normal form. So in the previous video, we discussed about the Chomsky normal form and what are the specified standards to right hand side of the production to maintain a normalization. So here in a Chomsky normal form, we have rules like the right hand side of the RHS should be having a terminal, that is only terminal, and two non-terminals. So here this is about the C and F, Chomsky normal form. It is having the rules like the right hand side of the production rule only having the terminal and a second production rule which is having the only two non-terminals. So this is about the Chomsky normal form and now we will discuss about the Greibach normal form. So here the Greibach normal form is a production rule satisfies one of the following conditions. So in the Chomsky normal form we have two conditions like that. Here also we have a conditions like a start the symbol generate epsilon, for example S tends to E. So if it is the grammar contains this kind of production rule, that is belongs to a GNF, Greibach normal form. And one more condition, the non-terminal generates a terminal. So here the right hand side RHS. So right hand side only terminal. And this is one condition. And one more condition, the non-terminal generates a terminal which is followed by n number of terminals, non-terminals. So here n only terminal and non-terminal. So here terminal followed by n number of non-terminals. So like that, these are the two conditions to satisfy the Greibach normal form. So here we discussed about the normalization. Here in the right hand side of the production rule, we have to maintain some standards. So for that one, we want this kind of conditions. So in the Greibach normal form, we have three conditions. So what are those in the sense? The production rule which is having the epsilon is also considered as a GNF and only terminal which is also represented as a Greibach normal form. And the terminal followed by the non-terminals, n number of non-terminals. So this is also one condition. If we satisfy these three conditions in the grammar, that is the grammar is there in the normalization, Greibach normalization. And here we will take an example Z1. Z1 is a grammar. So in this one, these are the production rules. So here the production rules are S tends to A, capital A, B. So we will see, we will check that whether this production rules right hand side is having the conditions or not. These three conditions will satisfy or not. So here RHS, so this production rule, it is having the terminal and followed by two non-terminals. So this condition is satisfied. So this is the production rule which is in the GNF. GNF, Greibach normal form. And here a terminal which is followed by the non-terminal. So this is also a Greibach normal form condition. And here terminal which is followed by the non-terminal. So this is satisfied with the Greibach normal form. And here only terminal. So this is also second rule we will satisfy. And B tends to B, small b and capital B. So this is also terminal which is followed by the non-terminal. So this condition is also satisfied with the third condition. And here only terminal. So only terminal. So which is all the production rule which all belongs to the Greibach normal form. So Greibach normal form. So this is the conditions which are there in the Greibach normal form. First one is terminal. The start symbol generates a epsilon symbol. So suppose here if we have this is the start symbol, it is having the epsilon. This is condition. This grammar is also a GNF. And here the non-terminal which is generating it only terminal. So this like this. So only terminal. So this kind of condition is also there in the Greibach normal form. And here the terminal which is followed by the n number of non-terminals. So these are the three conditions to satisfy the Greibach normal form. And the grammar. So if it is having in the normal, context-free grammar is not there in the standardized way, we have to convert that to a Greibach normal form. So how to convert this context-free grammar to a Greibach normal form? We need some steps we will discuss. So steps to convert a Greibach normal form. Context-free grammar to a Greibach normal form. Here there are 4 or 5 steps we require for the conversion of context-free grammar to the Greibach normal form. So in the first step, check if the given CFG context-free grammar has any unit productions or null production and remove if there are any. So here this removing unit production and null production and epsilon symbols, these are all comes under the minimization of CFG. So we will refer the previous videos for the minimization of CFG, minimization of context-free grammar. And here in that one minimization, we require the steps like removing unit productions and null productions, use null or useless symbols, and epsilon production. So these are epsilon productions. So these are comes under the minimization of CFG. And second step, check whether the CFG is already in CNF and convert it to a CNF if it is not. So here in the second step, what we have to do? So CNF refers Chomsky normal form. So in the previous video, we discussed about the conversion of context-free grammar to a Chomsky normal form. So in that one, we have a conditions like Greibach normal form is having the 3 conditions like that. In the Chomsky normal form also, we have the conditions like the right hand side of production rules. So only terminal, and second one only two non-terminals, and also epsilon symbol in the starting symbol in the start. So these are the 3 conditions in the CNF, Chomsky normal form. So if the grammar is not there in the CFG, we have to convert that to a CNF. So first step is we have, if the grammar is having the CFG, the given context-free grammar is having the like useless symbols and null productions and unit productions, we have to remove that one. Later we have to convert the given grammar CFG into a CNF, Chomsky normal form conditions. After that, third step is change the names of non-terminal symbols into some AI in ascending order of I. So here, let me take this example and we will write this ascending order of assigning some non-terminal names to the given grammar. So here suppose we have the terminals. So let me write the grammar first. The grammar which is having the V, T, P and S. So these are the grammar. So in this one V is nothing but non-terminal symbol S, A, B, C. So these are the non-terminals and terminals are B, comma A. And next production rules and the start is S. So this is about the production grammar for the given context-free grammar. And here we have to assign a names for these production rules like ascending order. So here if I assign S tends to A1 and C tends to later, after this one we have a C, and after that a non-terminal is there, and after that B is there, and like that we have to write and we have to assign some names to this production non-terminal symbols. So here C tends to A2 and A tends to A3 and B tends to A4. So like this, in the third step, we have to assign the non-terminal symbol names with this ascending order. So this is the third step, and after that one, so let me write this. After assigning some names in ascending order, we have to convert this grammar to this names. S is nothing but A1. A1 tends to C is nothing but A2, A3, A4, A4. And next B is nothing but here A4. So A4 tends to terminal and S is nothing but A1 and B is nothing but A4. And next C tends to B, A tends to A. So this is the, after third step we got the grammar like this. And next step is alter the rules so that the non-terminals are in ascending order such that if the production is of the form I tends to AJ X, then I greater than J and should ever be I less than or equal to J. So here we have to assign, we already have the terminals, the production rules like this. So here A2, A3, A2, A3, A4, A4 and next A4 tends to B, A1, A4, B, A1, A4, C tends to, capital C tends to B and capital A tends to A. So suppose in the fourth step we have to take the situations like if the non-production rule is having, non-terminal is having right hand side, it is having the I, this if it is I and this is the J. So here if the I, this J like 1 greater than 2, it is this production rule we have to leave as it is. And if this kind of production rule is happened, so here in this one 4, I is equal to 4 and B here 1, so 1. So this kind of production rules, if it is this kind of production rule, we have to change that. So we have to change or we have to substitute that values. So with that previous another production rules. So here how to convert these production rules we will discuss in the next coming example. And after this is the fourth step. So fourth step, we have to identify this kind of productions. So here I less than greater than symbols are there. We have to remove and we have to leave as it is like this. And fifth step is remove the left recursion. So in case of both here A4 tends to A4, this is the example of left recursion. So A4, 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 this kind of production rule is there. So this is 4 and 4. So this is a condition. So in this type of condition, this is called as left recursion. Left recursion. So we have to, in the left recursion, we have to add a new symbol. New symbol. So how to add a new symbol, we will discuss with the example. New variable we have to add, and we have to remove this entire production, and we have to substitute this with the new production rule. So, and we will discuss more with this type of conversion with the example. So here is the example we have taken already. So first step is, if there is any non-terminal useless symbols or null production rules are there, we have to remove that one. So there are no unit productions are there, all are terminals, non-terminal, 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 non-terminal. So here non-terminal, non-terminal. So if you observe this one, this is the first step. There is no requirement of first step. In the first step, we have to minimize the grammar in case of any useless symbols or unit productions are there. So in this grammar, there is no unit production and there is no useless symbols. And the second step is, so we have to convert this CFG to CNF. CNF. So here in the CNF only, terminal is one condition and non-terminal is one condition. So here we will check whether this given grammar is in CNF or not. So here the right hand side is having the non-terminal. So this is satisfying the CNF, and here also non-terminal. This is satisfying the CNF conditions, and here also terminal which is satisfying, and non-terminal, this is also satisfying. This is terminal, only terminal, and this is also only terminal. So that by seeing this grammar, we can say that the given grammar is in the Chomsky normal form. So this is the second step. If the grammar is not there in the CNF, we have to convert. And here the second step, so CNF, it's already there. There is no requirement to change to CNF. And third step, we have to assign some values. So new variable symbols. So here we will assign in the ascending order, like S tends to A1 and C tends to A2 and A tends to A3 and B tends to A4 and V tends to V already there. So these are the four non-terminals, and here we will write this grammar. So here A1 tends to, so this is the third step. So A1 tends to, C is nothing but A2, A3 and A4, and second production rule, A4 tends to B, and S is nothing but A1 and B is nothing but A4. And next C is nothing but A2 and A2 tends to B, and A is nothing but A3 tends to A. So this is the step, third step, we converted into a new symbol. So here we taken a new symbols in ascending order. We will check whether these conditions are satisfied or not. So I greater than J, I less than J, and I greater than or equal to J. So here 1 greater than 2. So this is correct. And here this is also 1 is correct. And here we have to check. So here 4 is there, and here right hand side is 1 is there. So we have to change that equation. So here in the third step, we have to take this production rule, we have to simplify this one. So how to simplify this one? In the sense, we have to substitute this value. So B, so here we have the already we have the production rule A1. So we will substitute this A1 with this in this production rule. So here substitute A1 tends to A2, A3, A4, A4 in this production rule. So here B already there. So instead of A1, we will substitute these two production rules, A2, A3, and we also have A4. And next A4, A4, and also we have A4. We substitute it. This is the substitution, and we have A4 tends to A2, A3, and A4. A4 is there, and A2 tends to B, and A3 tends to A. We will leave like that only. And here we will observe this A4 tends to, so B and B. So we will observe this again. This condition is not happen. Not first condition is not satisfying. So that here 4 is there and here 2 is there. So we have to minimize this one. So minimization. So here 4 is there, and here we have already A2 is substituted. A2 we will be substituting with the B terminal. So here B is substituted, and A3, A4, and A4 we will write as it is. And here already this, if you observe this one, in this production rule, A4 tends to terminal and non-terminals are there. Terminal, non-terminal. So that we don't want to change this. It's already satisfying the condition of GNF, Greibach normal form. So we are leaving like that, and here we will observe this A4 is there and here A4 is there. So in this is the condition, second condition, which is we have to change that. So this condition, if it is a condition like this, we have to change that, and this is also at the same left hand side and right hand side is equal number. We have to go for the left recursion. Left recursion. So here in the left recursion, what we will do? So in this is the fifth step. So in the left recursion, we will add a new terminal, non-terminal symbol. So here we will add a new non-terminal symbol Z. Z tends to, here we have the production rule. Which one we have to edit? A4 tends to A4, A4, A4. This is A4. So this is the thing we have to edit. So in this place, we will write the new non-terminal symbol, that is A4, A4, Z, and A4, A4. So this is the thing, newly added production rule. So if we will substitute this production rule in the entire grammar. So here we will write this entire grammar, and in this production rule also we will substitute. First let me substitute this new terminal, new non-terminal symbol. So B. So I am writing remaining part B, A3, A4, and here we have to substitute. Instead of this one, we have to substitute this production rule. So this production rule, how we will substitute? So here we will write this B tends to A4, A4. So here we will write BZ. We will substitute this with the new non-terminal symbols. So B, A3, A4, Z. So instead of this A4, 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 we will write this new non-terminal symbol, and again we will substitute with the remaining production rule, the combination of this production rule. So here we have the entire B, A3, A4, and BZ, B, A3, A4, Z. So this is the conversion. After converting this, after removing the left recursion, we have, this is the production rule. And let me check that in this production rule all the conditions of GNF are satisfying or not. So this is the terminal which is satisfying. Terminal is followed by the non-terminals. So this is satisfying. The terminal which is followed by the non-terminal, and this terminal which is followed by the non-terminals. So this entire production rule which is satisfying the GNF. And let me write entire grammar, and we will check whether all the production rules are satisfying this Greibach normal form or not. So here the first one, A1 tends to A2, A3 and A4, A4. So here, so both first I, J combinations which are, these are satisfying. So here in this also we have to change this. Why? Because there is not satisfying this production rule which is not satisfying the Greibach normal form. Why? Because both are non-terminal. So we have to change that to a terminal which is followed by the non-terminal. So here for this one we will substitute this A2 tends to B. And here A4 also we have to substitute. So what is this A4? So A4 we have to substitute all this equation with in this production rule. So let me write. So here we will substitute A1 tends to A2. So A2 tends to B. So B which is followed by the terminal. So we will write, and A4 we will substitute this entire production rule in this equation. So here B, A4 and B, A3, A4, A4 and B, Z, A4 and B, A3, A4, Z, A4. And this is the, after substituting these two values, we will get this production rule, and we will check this first production rule which is satisfying the Greibach normal form or not. So G, terminal which is followed by the non-terminal. So this is also terminal which is followed by the non-terminal, and terminal which are followed by the non-terminal, and terminal which is followed by the non-terminal. So all are satisfying. In this A1 production rule, all the production rule, right hand side of the production rule which are satisfying the Greibach normal form condition. And here A2, A4. So this we will write, or we already checked with the entire production rule is having the Greibach normal form conditions or not. We will write entire grammar and B, A3, A4, Z. And here one more new variable we have added. So we will check for this one. So A4, A4, Z and A4, A4. Here also we have a not condition satisfying of the Greibach normal form. We will convert this and we will substitute this A4 value in this non-terminal condition. We will get, so Z tends to A4. A4 is nothing but B. So here B, A4Z, B, A3, A4, A4Z and BZ, A4Z and B, A3, A4Z and A4Z. And this is only this part finished, and this for this part also we have to finish this. A4 is there. So here we will substitute this only A4 and we will add this production rule A4, B, A3, A4, A4 and BZ, A4 and B, A3, A4, Z, A4. So finally this is the condition. These are the, we will check whether this entire grammar is having the Greibach normal form conditions are satisfying or not. So here all terminals which are followed by the non-terminal, so entire this grammar which is converted to a Greibach normal form. So this is how we are converting a context-free grammar to a Greibach normal form, and we will discuss with the conversion of another example. We will have a grammar. This is a context-free grammar, so that we first step is we have to minimize this grammar. So in the minimization, we have a useless non-term, useless symbols and unit productions are there or not. We have to check, and whether this it is having the epsilon symbols or not. We have to check. So these are the three conditions which are having in the minimization of context-free grammar. And here this context-free grammar which is not having the minimization, there is a no requirement of first step is not required. Why? Because there is a no useless symbols. By seeing this, there is a no useless symbols and unit productions are not there, and there is a non epsilon symbols are not there. And here in the second step, if there is if the grammar is not there in the CNF, Chomsky normal form, we have to convert it. So what are the conditions for the Chomsky normal form? In the sense, right hand side of the production rule which is having the two non-terminals or only terminal symbols. So these two conditions are satisfying in this grammar, so that there is a no requirement of second step, that is a CNF step. So minimization. So in the first step we have to minimize, and second step we have to convert the two grammar to a CNF, and third step in this one we have to assign values. So in the third step we will assign values. So here S tends to A1, and A tends to A2, and S tends only two are there. So we will write this. Only two non-terminals are there. We will write this production rules like A1 tends to A2, A, and A2 tends to A1, B. So these are the two production rules. So here we will convert. In the third step, if the condition which is having I and J, so this type of condition which is satisfied. So this is the first one production rule which is satisfying. So this production rule which is satisfying this one. So we have to remove this kind of production rules and we have to minimize that one. How to minimize? So we will write the production rule A1 as this, and we will take the A2, and here we will substitute this A1 value in this production rule. So here we will substitute this kind of production rule. So here A1 tends to A2, and A. We have to substitute this one. So A2, and A1. So here A1 and B. So we have substituted only A1 value, and we have the production rule like this. In this one we will check, and we will write A1 also. A1 tends to A2, and A. So we will check in the fifth step whether these conditions are matching with the Greibach normal form or not. Conditions satisfying the Greibach normal form conditions or not. So here this right hand side, it is having the two non-terminals. So here these three non-terminals are there, and also we have the left recursion. So A2 is there, A2 is there. So here we have to change this A2 left recursion. We have to perform the left recursion first. So in the fifth step we have to do the left recursion. So for left recursion, we have to add a new non-terminal symbol, that is Z. So in the Z, here we will write this Z is equal to A2, 3 is there. So here A2 is there, and A2 Z, and A2. We will introduce the new production rule. Here we will substitute this production rule in the A2. How we will write? So A2 tends to, so instead of this entire thing, we will write this one. A2, Z with A1, and B, A2, Z, and here also A1, A2, and B, A2, A2. So this is the substitution. After substitution, we got the production rule like this. And here we will add the production rule A2, A2Z and A2, A2. And here A1, we will write entire grammar here. And these are the grammar after conversion. After performing all the steps, we have this grammar. And here we will check whether all the grammar is satisfying the Greibach normal form conditions or not. So here the Greibach normal form which is satisfying in the A2 production rule. So this all or production rule which are satisfying the Greibach normal form conditions. So here in the Z and A1 we have to substitute the values. So here first we will write A1. So here A2 is there. So in this one A2 we will substitute this production rule. We will have a production rule Greibach normal form standardization. So here we will write instead of this A2 we will substitute entire this production. So A1, A2, A2, Z, A2 and B, A2, A2, Z, A2 and A, A1, A2, A2, A2 and next B, A2, A2, A2 and A. So this is how after converting this entire production rule with the normal Greibach normal form conditions, so all are satisfying the Greibach normal forms. The terminals which are followed by the n number of non-terminals. So all are only terminal also satisfying. So this is the A1 which is the production rule which is in the form of Greibach normal form. And here we will write also Z. A2 we will write as it is. A, A2, A2, Z, B, A2, A2, Z, A, A1, A2, A2 and B, A2, A2 and Z. We have the production rule A2, A2, Z. So if you substitute this A2 value in this production rule, and this both A2 and A2, we will substitute this entire production rule in this production rule, we will form a Greibach normal form grammar. And here we will write this A2 value. So here A1, A2, A2Z, A2Z. And here also we have to add this A2Z to this all production rule. A2Z and A, A1, A2, A2, A2Z and B, A2, A2, A2Z. So this is the first part done and we have to add this one also. And A2, so we have to add A2 to the all the production rule. So A, A1, A2, A2Z, A2 and next B, A2, A2, Z to the A2 and A, A1, A2, A2, A2 and B, A2, A2, 8. And this is how we converted the production rules of context-free grammar to a Greibach normal form. So this is all about the production rule. If you check all the grammar of the production rule, we have the all are satisfying the Greibach normal form conditions. So here by this conversion, we will convert a context-free grammar to a Greibach normal form. So let me summarize this conversion of a context-free grammar to a Greibach normal form. In the first step, if there are useless symbols, we have to minimize that grammar, given grammar. And the second step, we have to do the context-free grammar conversion to a Chomsky normal form grammar. And next step, we have to assign some new variable names. And after that, we have to check the two conditions and if there is any left recursion kind of thing, we have to add a new variable and we have to substitute all the grammar if there is a condition satisfied with the Greibach normal form conditions or not. We have to check entire the grammar whether the conditions of GNF are satisfying or not. And these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.